Review page thrown in here. Hopefully you've given it a try. Now let's check how you did. The first part is just assessing that we're okay with determining the different shapes of the data. So in this case, S over all the plots that are roughly symmetric. So remember, symmetric just means you can divide it left and right and they'll be basically the same. So the first one and the second one, and part F and part D and H, those all look pretty symmetric to me. You could imagine drawing a line down the middle of any of these and the left and right matching up fairly well. The remaining plots, we need to draw R for right skewed or L for left skewed. So remember, the direction of the skew is indicated by where it's trailing off to or being pulled toward. So this is being pulled toward the right, so this is right skewed. This guy, part E, is being pulled toward the left, so that's left skewed. And I would say G is also kind of left skewed a little bit. This is a bit of a strange shape. It's definitely bimodal, has two main areas, but in a way it's kind of trailing to the left. That might be the best to describe it. All right, hopefully you've mastered the names of the shapes of the distributions. Now let's check out the relationship between centers, different measures of center, and the shape of the distribution. So our first plot here is fairly symmetric. Left and right are about the same. So our balance point, or the mean, should be right about here. And also the halfway point should be about the same. So mean and median should be basically the same in this case. So this one should be option C, where mean and median are about the same. The next example, we're skewed to the left, or it's trailing off to the left. So remember our general rule, the mean is pulled toward the skew. So the mean is going to be pulled toward the left, and the left represents smaller numbers, so the mean will be smaller. It's pulled in that direction. So that's option A, mean is less than the median. Then our last one, obviously, that's going to be option B. And if we want to think about it, the skew is to the right, so the mean will be pulled toward the right, meaning the mean will be toward the larger numbers. The mean is greater than the median. Then our last one here is considering which histogram would yield a larger interquartile range. So the important part to notice on these two first is that the x-axis is the same in both of these. They're both between -1 and 1. And now remember what IQR measures. It measures the spread of the middle 50% of the data. So if you look at the first one, there's not a lot of data in the middle. So I'm going to have to go out further in either direction to get 50% of the observations, because there's, again, not as much data in the middle. Whereas this one, most of the data is crammed in the middle, so I don't have to go out very far to get 50%. The data is all right here, so it doesn't require me to go out very far. So in terms of having a larger interquartile range, that would definitely be option A, because we have to go further to get that middle 50% of the data. Okay, so that was just a little bit of a review. Let's check out this next section. Here we're going to be doing a test for outliers in the data. So the first thing to test for outliers, and I should mention, make sure you know these formulas and that you're comfortable with this section. All right, so our 5-number summary, we've seen it before. If you remember, it was in the bottom of the one variable stat screen on our calculator, is just looking at the overall spread in the data, our minimum to our maximum. Then breaking it into quarters. So we'll divide it in half first. have our median. And then our first, divide the bottom half in half again. So Q1. Sorry guys, my pen is and computer are having weird communication issues right now. And then I'll try and figure it out for the next video. And then divide the upper half in half again. And that's our Q3. All right, helps you know I'm human too, right? Have a little roughness in the videos. All right, so our test for outliers, maybe let me switch to using some text here. So first thing we need to do is define our interquartile range, which you should be familiar with, we've seen before. So our interquartile range was our Q3 minus Q1. That measured our spread of the middle 50%. Next, we're going to take that middle 50% and stretch it out just a little bit. We're going to call that next step, strangely enough, the step, which is going to be 1.5 times the IQR. So middle 50%, multiply it by 1.5, just stretch out that spread a little bit. Then we're going to calculate something called our lower fence. And I'll usually just refer to this as LF for shorthand later on, but just so you know what it stands for, our lower boundary. And this boundary is going to tell us any data points smaller than this are going to be considered outliers or unusually small. So to calculate this, we're going to start at the first quarter of the data, or Q1, and we're going to go back that step amount. And again, if there's any data point smaller than this, they will be considered outliers. Okay, and then we're going to do the same thing on the other side to see if we have any large observations or large data points. So this one is called our upper fence, and we're going to start at Q3, the top 25%. So notice Q1, lower fence, you started with Q1, the bottom 25%. Upper fence, you start with Q3, the top 25. So this one is going to be Q3 plus the step amount. Make sure you have those signs correct. And any points beyond this beyond this are going to be considered unusually large observations or outliers. So here I'll say any points larger than this are outliers. So this gives me our boundaries for what's considered an outlier. Never say that these lower and upper fences themselves are outliers. That's a common mistake. All right, let's actually take a look at an example. You may want your calculator for this, up to you. But we've got a little bit of dated data here. Sorry about that. It's the first 3 seasons of Walking Dead. But we have a random sample of 20 different characters, and we want to find the 5-number summary and any outliers in this data. So we have their characters and their number of zombie kills. So if you want to enter the data in your calculator and use the one variable statistics to find the quartiles, go for it. I'm going to find it by hand real quick. It's not too bad since I have the data in order for you. So we have 20 data points, so I can split it half in half. The first 10 and then the second 10. So my median is going to be the average of 6 and 7, which would just be 6.5. Then I need the middle of the bottom half for Q1. So the middle of these 10 data points is going to be split right here, the average of 3 and 4. So Q1 should be 3.5. Same thing on the top half. I need the middle of these 10 data points, so between 15 and 16. If you do 14 plus 19 and divide by 2, you should get 16.5. 16.5 for Q3. So our 5-number summary, I'm going to try and type as much as I can so we don't get that strange pen problem. So our 5-number summary is going to be our min, Q1, the median, Q3, and the max. So in this case, our minimum observation is 1. We can see that easily. We found Q1 to be 3.5. We found our median to be 6.5. And our Q3 to be 16.5. And then the max down there is Rick with 91 zombie kills. So there's our 5-number summary. Now that we have our 5-number summary, let's come up with a quick sketch to get a feel for this. Again, some of these topics should sound familiar. You've probably seen them before. But let's go ahead and draw our box plot for this. So when you draw your box plot, make sure you always draw your scale first. Don't try and put these numbers on it first. Go ahead and just draw a rough scale. So I'm going from 1 to 91 in my data. Let me maybe count by tens to make that easy. So 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. All right. So first thing we want to do is draw a box around our middle 50%. So remember, that's Q1 up to Q3. So Q1 is 3.5, about right here. Q3 is 16.5, about right here. So I'm going to draw a box that covers that distance. Q1, 3.5, to Q3, 16.5. And then we're also going to toss in the median here, 6.5. So somewhere like this is my median. So Q1, median, and Q3. Sorry about these little lines going beyond on the box. All right, then we just need to include the min and the max. So just draw those as lines in either direction. So the min goes out to 1. Our max goes out to 91. So there's our box plot. It gives us a feel for the middle 50% of the data is represented by the box. So it's kind of mostly smaller values, but I've got this right skew, larger observations being pulled in this direction, but there aren't many of them. The bulk of the data is down here with the box and the smaller numbers. So now we need to officially test and see if we have any outliers in the data. So let's go through our Outlier test for this. And we have all the numbers calculated based on our 5-number summary above. So we just need to go through our steps. So first thing, remember, is find our IQR. And that's the spread of the middle 50%. So in this case, our Q3 was 16.5. Our Q1 is 3.5, so that gives us a spread of 13 for the middle 50% of the data. Next, we need to find our step. And as a reminder, that's 1.5 times our IQR. So in this case, we're taking 1.5 times our 13, spread of the middle 50, and that gives us 19.5. All right, now we're finding our boundaries for what's considered an outlier. So our lower fence, again, I'll start abbreviating it LF, feel free to do the same, is the lower 25%, Q1, and I'm going to go back that step amount. So in our particular problem, our Q1 was 3.5, and I'm going to go back that 19.5, my step amount. And that's going to give you negative 16. Go ahead and write down negative 16, even though you're saying it's impossible to have a negative 16. No problem. We're not saying we actually have that. We're just giving a boundary to see if we have any data points that would be considered unusually small. So here, you're right, we don't have any observations that are negative, so we don't have any really small observations considered outliers. Let's look at the other end, our upper fence. Check out the upper extreme, Q3, plus our step amount, so go up the upper 75%. And our Q3 was 16.5, plus our step of 19.5. Again, make sure your signs are good, and you get 36. So this tells us any data points beyond that would be considered outliers. So let's check out our data. 36 was our boundary. Down here we've got 2 data points that are beyond 36. We have 61 and 91, Rick and Daryl. If you watch the show, that probably makes sense from the first 3 seasons. So 61 and 91 are outliers because they go beyond that upper fence. They're considered unusually large values. All right, last thing on this, we're going to sum this up with a modified box plot that highlights any outliers. And I think the box plot helps give you an idea of what this test is doing. Remember, this represents the middle 50. So the idea of my boundaries are I'm going back a certain amount from the bottom of the box, going up a certain amount from the top of the box, and anything that lies outside of those regions is considered an outlier. So let's check out our modified box plot. And you're going to start in much the same way. You're going to go ahead and draw your number line there and draw a box for that middle 50%. So I'll use that same number line, starting at 0, counting by tens. And then our box, we had around Q1 of 3.5, Q3 of 16.5. Oh, it's going crazy on me again here. Sorry about that. And pretend that doesn't go over the box, it just makes up the box. And then our 6.5 for the median, so our box. And then we're going to take off the lower part. We did not have any outliers in this less than direction on the lower fence, so just draw out to your min of 1. In the upper direction, we did have a couple of outliers. We're going to mark those with an asterisk or a dot. So 91 was an outlier, and then 61 was an outlier. So I'm going to denote those 2 unusual observations with dots, and then my line is going to go out to the largest data point that is not an outlier. So notice here, the next largest data point is 31. That's not considered an outlier. So my line here is going to go, some people think of it as kind of their quote-unquote new max. So the new maximum once you take out the outliers. So this goes out to 31, the largest data point that's not an outlier. And then you might want to add a little note to yourself here that notice the fences were not displayed on the plot. Fences do not, maybe let me make that caps here, do not go on the box plot, okay? Instead, we indicate with dots where our outliers lie, and then the lines go to the largest and smallest data points that are not outliers. Okay, so a little note of how that works.